Hi everyone. The goal of this video is to learn how to solve absolute value equations and again identify extraneous solutions. So we're going to take a look at some basic problems and then kind of extend our knowledge and apply from there. Level 1 says let's just solve the absolute value of x equaling some number. So starting with the absolute value of x equals -6. So what the absolute value does is it tells you a distance from 0. So like let's say I have 1 and -1 on the number line. How far are they away from 0? And the answer would be they're both 1 unit away from 0 because distance can't really be negative unless you're talking about direction, but that's another story. So they're 1 unit away from 0. That's why absolute value always becomes positive. So if I plug something in here, whether it's positive or negative, it's going to become positive. Okay, so absolute value of x equals -6 versus the absolute value of x equals +6. What do you think about these? Well, considering if I plug in something for x that's going to become positive, there's no way it's possible to have an output of -6. Okay, so this equation would not be possible, and any solution you get would be an extraneous solution because you can never have the output being a negative. Consider that for a second. That's where extraneous solutions come up. Now, if I take the absolute value of x and the output is 6, there's really two answers. If I take the absolute value of 6, it's going to equal 6. Or if I take the absolute value of -6, it's also going to be 6. So this one is possible. And either 6 or -6 will work. So I would say x is plus or minus 6. Okay, so oftentimes in absolute value, you're going to have two equations and two solutions. Although sometimes you make an extraneous solution because there's no way you can take the absolute value of something and have the output be a negative, and that's where extraneous solutions come from. Okay, keep that in mind, and we're going to figure out how to actually solve something like this. So there's two situations for where the absolute value of 3x minus 11 equals a positive 12, right? So if I just take the positive version of this, just 3x minus 11, like the positive version, whatever this number is here, that can equal 12. Or if I plug in like the negative version of this, 3x minus 11, it would also equal 12, which is what I said here. If I plug in +6 or -6, the output's going to be the same. Now, we don't have a number here, we have an equation, so I'm just taking the quote-unquote positive version of whatever this number is and the negative version of whatever this number is. Now, obviously, the positive number is not going to change it, so you really just have kind of what you see and then the negative version of that. Okay, and that's one way to look at it. So I'd actually solve this and say I have to add 11 to both sides. I get 3x equals 23. So x would be 23/3. That's one option. Now in this case, there's two ways to solve. You could distribute the negative, or really this value here is a -1, so you can divide both sides by -1. If you do that, you get 3x minus 11, because these cancel, equals -12. So what it's really saying is that this equation could either be positive 12, like it is here, or this equation could wind up equaling -12. So either way you slice it, whether you talk about the negative in the beginning or the end, you're going to get the same thing. So whichever one you understand better, I would consider that. If you add 11 to both sides, then we can solve this. I get 3x equals -1, so x equals -1/3. Again, the extraneous solutions, you're always going to want to check for by plugging back in. So if I plug in 23/3 here, 23/3 times 3 over 1 is just going to give you 23. 23 minus 11 is 12. The absolute value of 12 is 12, so that works. And if you plug in -1/3, it's going to work as well. You can test that on your own. I'm going to leave this one for you guys to try on your own. The most important thing we should have got from this problem is the setup here. So in one situation, you should have 3x minus 11 equals 12. In the other situation, you should take care of the fact that like you could plug in the negative version and still get the same output, which is what I did here. So anytime you solve an absolute value equation, you should have two different equations to solve from it. Okay, I hope that is our review, and I will let you try that one on your own. Right. The other thing to know about absolute value equations is you're going to follow the same steps you follow in any other equation to isolate x. So for example, in this one, I could subtract the 7 and then have 2 times the absolute value of -4 equals, I would have 24. And then I want to isolate the absolute value, so I could divide both sides by 2, just like I would without absolute value to kind of get rid of that multiplication. So then I just have the absolute value of x minus 4 equals 12. So I guess what I'm trying to say here is you always want to isolate your absolute value if possible. So isolate it, get it alone, get rid of the multiplying, the adding, anything that's bothering. So you can just focus on the absolute value piece and setting up your two equations. I'll let you solve the rest of that one on your own. Just something to think about. Solving is solving no matter what the solving equation looks like. You can always follow those steps that you know to be true. Now these ones are a little bit different because you have an equation on both sides, but you still only have one absolute value. So what this says, right, if I have the absolute value of x minus 3, it could be x minus 3 equals 3x minus 19. That's just what you see. The other option is, if you take this and make it negative, okay, you would still get the same result because you're taking the absolute value of that. So I'm going to set up that equation as well. So I have the negative, or the opposite version of x minus 3 equals 3x minus 19. And these would be the two equations you solve. So going ahead to do that, you have variables on both sides. You're going to want to move them to one side. So I here get negative 3 equals 2x minus 19. Get your numbers on the other side. So then I have 19 minus 3, which is 16 equals 2x. So x equals 8. That's one solution. The other solution, you can either divide by the negative or distribute it. It's up to you. Since I divided in the last one, I'm going to distribute in this one. So I have negative x plus 3 equals 3x minus 19. Okay, now get my variables all on one side. I have 3 equals 4x minus 19. Add 19. I would get 22 equals 4x. And x would equal 22 fourths. If you simplify that, it's 11 halves. So I have two solutions. We want to check for extraneous solutions. So 8 is probably the easier one. 8 minus 3 is 5. So the absolute value of 5, absolute value of 5 is 5. And then I have 3 times 8 is 24, minus 19. Is that true? Yes, it is. So x equals 8 will work. Let's do the other one for some practice here. So I have 11 halves minus 3 equals 3 times 11 halves minus 19. Okay, I'm going to pause the video and do this computation for the sake of time. You guys do the computation on your own and confirm whether or not the solution works. Okay, so I finished that computation over here. So I converted, let's see, 3 into 6 halves, and I got 11 halves minus 6 halves is 5 halves. 19 halves, or 19 is actually 38 halves. 3 times 11 halves is 33 halves. So then I have 33 minus 38 halves is negative 5 halves. And this is the equation I wind up coming up with. 5 halves equals negative 5 halves. Is that true? No, it's not. So in this particular problem, 11 halves is an extraneous solution. And again, the reason why extraneous solutions come up is because of the idea we discussed right here. But you may not always see it as clearly as that problem because it's kind of disguised by a bunch of variables here. So with that said, you should always check for extraneous solutions. And my only solution to this problem would be x equals 8. I'm going to leave this one for you to try as a self-assessment on your own problem. Okay, there's one more problem on the back. It's a challenge problem. I'm not going to go over it in this video, but if you want to stretch your brain and kind of really see how well you understand these concepts and give yourself a challenge, see if you can figure out how you'd approach a problem that has two absolute values. Okay, use whatever resources needed. You can Google it, do whatever, come in for help. But I'm going to leave that for you to kind of ponder. So with that said, I think the main things you need about absolute value equations are, how you set it up, because from there the solving is just, solving like you would solve a linear equation, maybe even a quadratic, but that shouldn't be too challenging. Okay, as always, check for extraneous solutions, write these hints down to yourself, and if you have any questions, please come with them. Have a great rest of your day.